Just to start our last lesson in this unit, you guys, I put up the answers that you should have had from yesterday, where we were just gleaning the key features that we know when we don't have to change forms. So notice there's a lot of blanks in the ones that have standard form. And we're going to finish filling in this chart a little later on. So let me get this thing out of the way. There, have a look at your answers and these answers. And then we'll continue on with this chart in a little bit. Okay. We're going to determine the x-intercepts, axis of symmetry, and vertex, and that means we're going to have a little bit of work to do and come up with a sketch. Sometimes it's easiest to complete the square, not very often. Sometimes it's easiest to factor. And our best choice is always to try and factor, because we can always complete the square. We just might cry. So right now it's in standard form. And what do we know from standard form? We know it opens up, has a normal step pattern, and we know that the y-intercept is -24. So my thought process is, if possible, factor. Otherwise, we will have to complete the square. So for this one, I'm going to try. I go through the thought process of factoring. Is there a greatest common factor that's more interesting than 1? No. Is it a difference of squares? No. There are 3 terms, so it's a trinomial. Is it a simple trinomial? Yes, actually it is, because the a value, which is invisible, is 1. So if it's a simple trinomial, I can factor it by setting up 2 sets of brackets. There would be an x for the first term in both. And if it's factorable, I should find 2 numbers that multiply to -24 and add to -2. There just so happens to be 2 such numbers, -6 and 4. This one is factorable, and that just means that there are nice x-intercepts. If it's not factorable, you still might have x-intercepts, they're just not going to be pretty. So this tells us, once we have it in factored form, that our x-intercepts are 6 and -4. We have been asked for the x-intercepts and, oh dear, the axis of symmetry. So if we have the x-intercepts, then the axis of symmetry lies between the 2 x-intercepts. We can find it by averaging the x-intercepts. So I have 6 and -4. To average, we add them together and divide by 2. So 2 over 2. My axis of symmetry is x equals 1. So let's just quick put on our graph what it is that we know. I know I have an axis of symmetry, or a fold line. The middle of my parabola is x equals 1. I have 2 x-intercepts, one at 6, an x-intercept at 6, and an x-intercept at -4. 1, 2, 3, 4. 1 there. Okay, I know that it opens upwards, and I know my y-intercept is -24. So it's not to scale. So my vertex must be a little bit lower than -24 so that I could have an upward curve. Okay, what else have we been asked for? The axis of symmetry and the vertex. So we need to know the vertex. Exactly. Our vertex goes through the axis, or lies on the axis of symmetry, which is at x equals 1. So I know my vertex will look like that. To find that y value exactly, I'm going to substitute x equals 1 into the equation. You can substitute x equals 1 into the original equation, y equals x squared, subtract 2x minus 24, or in factored form. I'm going to put it in factored form. It's faster for mental math. Y equals, I'm going to put a, let me just write it out here. X minus 6, x plus 4. I'm going to substitute 1 for every x value. So 1 subtract 6 and a 1 add 4. 1 subtract 6 is negative 5. 1 plus 4 is positive 5. Weird. Negative times positive is negative, and 5 times 5 is 25. That matches what we expected to see on our graph. The vertex is 1, negative 25. This one I have in vertex form, and I have been asked to determine the y-intercept and x-intercepts and sketch the curve. We could change forms. We could expand this and write it in standard form, and then we would know the y-intercept. Then we would have to factor to get the x-intercepts. Let's see if we can do it without. If I want the y-intercept, I am looking for a point that looks like that. So if I substitute x equals 0 into my equation, I can find the y value of the y-intercept. Here we go. Let's substitute a 0 for x and solve. 0 plus 2 is 2. So I have 2 squared. Subtract 4 is 0. So I have a y-intercept of 0, 0. I am looking for the x-intercepts as well. For the x-intercepts, I most certainly don't want to change forms because I would have to do it twice. For my x-intercepts, I know I could have 2 of them, potentially, and the y value is 0 in both cases. So I'm going to substitute y equals 0 into the equation. We tried this yesterday. We're going to try again. 0 equals x plus 2 squared, subtract 4. And I want to solve for x. So I want to get x by itself. I'm getting rid of all the extra stuff around it. So I'm going to first of all add 4 to both sides to get rid of that. Subtract 4. I have 4 equals x plus 2 squared. The next thing I'm going to do is get rid of the little square. To get rid of a square, you square root. But it is possible to square a positive number to get 4, or square a negative number to get 4. So I need to think about both of those possibilities. Last thing I'm going to do is subtract 2 from both sides. And I am going to have plus or minus square root of 4, subtract 2. There are my 2 answers. X equals positive root 4, subtract 2, which is square root of 4 is 2. 2 subtract 2 is 0. So x equals 0 is one of my x-intercepts. The other one is negative root 4, subtract 2. Negative square root of 4 is 2. Negative 2 subtract 2 is negative 4. My other x-intercept is negative 4. 0, 0. Negative 4, 0. My y-intercept is 0, 0. My vertex coming from this is negative 2, negative 4. Always opposite in brackets. 1, 2, 3. There we go. Negative 2, negative 4. There is my parabola. I'm trying. And so we can glean information by changing forms or solving and substituting.